Okay, so I guess we're live. Are we? Okay then. Sorry, some mic issues, but it should be fine. Okay then, so let's do something with Blender, and by something I mean let's create some fancy mathematical thing called Lorenz System or strange attractor, something like this. And what's the deal? So basically we have a three-dimensional space here, and things in this space have location as this vector of three values. And there are some math formulas which allow you to plug these values into it, and they spit out a new vector of values. And this new vector could be treated as a direction to move the object. So for example, this vector says we have to move it here, and we move it a little bit, but in the given direction. And so we'll get a new position of this object, and we put this new position into these formulas, and they'll give us a little bit different vector. And so basically attractors, Lorenz system in particular, is a formula that will move things from wherever they are to a certain space, and they will be attracted and we will be moving in orbits like forever. And the trajectory of the movement is quite interesting, so it will produce nice looking results. But the main issue that things that Blender has right now are not capable of implementing this effect in Blender, like with the default modifiers, or what we have, force fields for particles. So some coding are required. And so let's go to scripting and let's create a new script. So first things first, we have to define these Lorenz system equations. Basically, what do I want? I want a function. Let's call it Lorenz. It will take some location L as parameter, as an input. This location is basically a tuple of three values that Blender uses as location of objects. So here I can on extract these values like so. And then I have to define some constants as Lorenz equations, Lorenz systems, kind of differential system. We need to have this dt step size. It should be quite small to have a smooth orbit, but if it's too small, then movement will be really slow and you'll have a wait for a long time. But if it's kind of big, you'll get a very not very smooth path. Here I'll define some Lorenz, some constants for the Lorenz system. It will require like sigma. Here I'll be using as rho. It will be 28, and b it will be 8/3. Okay, so we have our constants, and let's calculate dx. So how far should we move along x-axis? So let's have dt multiplied by whatever we have here, and here we have s times y minus x. The equation's kind of straightforward, and here we have dy. It will be dt times x times r minus z minus y, and dz equals dt times what we have here, x times y minus b times z. So let's return this new value. We'll be returning not like these values of a vector for direction, but we'll return a new location. So we'll update all location with calculated values. dy and z plus dz. So and then we need something to move, and here we have a couple of options. We can have a single object and create a lot of keyframes, and this object will move around on the Lorenz attractor's orbit trajectory. Or we can spawn a lot of objects and get some shape. But I'll go with a different approach. Let's remove this default cube and let's create an icosphere. I'll create a particle system and disable forces on these particles, like no initial velocity, no gravity force, and let's spawn particles from the sphere's volume. So I'll move particles around. It will give a lot of freedom adjusting number of particles, the lifetime, and so how long they will travel along the Lorenz system's trajectory. And here goes some more complicated stuff, because for now it's not that easy to iterate over particles and set specific location for each of them. And I hope with Nodes Everything project it will be easier, and it will be something like in Houdini, something like we have in Houdini. But for now we need to do some Python magic. Let's import some useful stuff, and let's get an object to work with. I'll just get it by name. Like a sphere. We can use like a context, an active object, but like, or we can go with, yeah, let's go with some fancy name. And one particular issue with it is that we cannot just get this object's particle system and iterate over particles. There are a lot of things I'm not that very familiar with, but we want it to be, we want to have particle positions evaluated for every frame. So what I found is that there are things called handlers, application handlers, which and user can assign some custom code to be running on this handler's trigger. So let's go and assign something to handler called frame post change. Let me check quickly here. API apps handler. What we have? BPA, wrong app, not apps. Handlers. Frame change post. Yeah. Frame change post. So this function will set here will be running like, I believe it should be append, because we appending one more thing to the handlers. This code we'll put here will be running like after changing our frames. So let's create function for this handler. and this function will get a scene and dependency graph. With these things we have to do a couple of things. So let's get particle system from object we have, and we need to get like this evaluated version of this object, like everything that depends on this object, or everything this object depends on. Well, these things aren't trivial yet for me, but here we have a particle system available for us, particle systems. And like we just can get the first one, and we can get, like, I believe, particles right from here. Okay, so let's hope it works and we have our particles. One thing we have to check, if we at the frame 0, like a frame the animation begins with, sorry. And if so, we want to clear particle cache. Okay, that should make the work done. And from here we can iterate over each particles. Like this. And we can get a new location from what? Our Lorenz function. Basically, we can do like this. Also, yeah. So this thing should works like we'll click here, and yeah, we'll get an error. So what's wrong with it, and why do I have no anything? I didn't run it with console, so let's save it somewhere here on desktop. Okay, let me check the code. Okay, bear with me. Let's restart Blender with terminal. Okay, now I have a terminal. Yeah, so we have terminal. Let's try it and run one more time. So what we have? Okay, up. Yeah, I forgot to add actually add function to our handler, and okay, it's added, but every time we'll run this thing, if we'll make some modifications here there, we'll add one more Lorenz calculator to this frame change post handler. So first we have to clear everything we added before, and now it should be working. So let's check if it's working actually. Let's hide a terminal. Yep, so as you can see, particles are flying around in a very interesting trajectory. So things I want to adjust right now is like animation length. Let's add 100, and emission works forever, and lifetime let's add it to 100, and the amount a little bit more. So nice, isn't it? Well, you can play around with spawning, position, size of spawner, but in my experience there are two things I want to have added here about this thing. First, I believe speed should be reduced a little bit because step size is too big for me. So let's go to scripting and decrease step size like this, 3 times less, and run script to update the handler. Next thing is this thing moves too uniformly, like they have exactly same speed and they move like being stick on some kind of ribbon or something like this. So I want to add some randomness to the speed, but not like evaluating a random value every time we calculating a new position, because I want to single particle have same speed through all of its lifetime, but I want different particles having different speeds. So the thing I need is like some identifier of a particle, and I'll calculate random value using this identifier, and here I'll be iterating not over particles but over range from length of particles. So length function will give me a number of particles, and here I'll get I from 0 to number of particles minus 1, and I can get individual particle here. And here I pass basically identifier of a particle, of a current particle we calculate in position 4. Okay, so what's left is to calculate some random value sorry for this notification sound. So I can use random, but I'll go with math library and just calculate not actually random value, but the value that will be looks like a random value. So for example, we have I. Let's take a sine of it And let's add cosine of a divided by some value. Okay, and then let's make it rise it to some. Well, let's power it. Okay, and what and I need a what fractional part of it, I believe. Like it should be something like mod f. Like this. So this thing should give us a random value from 0 to 1. Let's try it. Let's paste it here. And okay, m is not defined. Import math as m. And let's define I as 1. Okay. I equals 2. Okay, I equals math domain error. Interesting. Maybe power's too big. Oh. Okay. What could it be? Okay, let's check. What's wrong with it? Okay, let's go simple root without any power. Okay, one thing to notice, it could be a negative value. Come on. let's go for I. Well, we have values that looks like kinda random values. But let's fix negative part of it. Do not remember, like math ABS or just ABS. Yeah, like this. This should do the trick. Come on, please copy this and paste it here. So we'll just multiply our dt by this rand value, but I do not want rand from 0 to 1. I want it to have like from 0.8 to 1.2. So to get it, I'll update random. Okay, I'll multiply it by 0.4 and add what should I add to it? 0.8, like this. Okay, let's run it and see what we have from now. Are there any variation in particle speed? Come on, what's wrong here? And let's check terminal. It says that BPI probe collection has no attribute location. So particles, yeah, sure it has no, because it should be like this. Okay. Actually, let's check if our thing works actually like 0, 0, but here it will be like 10. So we'll see significant difference in particle speed if there are any. We see some very strange results. You know what? I believe it may be some caching issues. So let's reduce number of particles and let's bake all dynamics. Okay. Yeah. Now we see that some particles have like really crazy high speed and some of them are barely moving. Good. So let's restore the right values. Save everything. Delete, bake, and bake it one more time. Yeah, beautiful. But particles live forever. So, we have something to render, but the thing is, I do not like the look of Halo render, and I kind of want this thing to have a proper motion blur. So I'll go with object instance for rendering, and let's use some icosphere as an object for instancing, and let's set up this object and icosphere. Good. Some kind of dramatic angle here, so they flow in from the corner and flying far away, and then start spinning like being trapped on some kind of black hole situation. Okay, let's set our camera to this view. Okay, not what I wanted, but okay. Where is it? Like local GZ, and let's move away a little bit. Let's away of no camera GZ. Like this, and let's increase an angle. Okay. Now let's switch to cycles. Save it. Let's check that we have GPU. Let's have CPU as well. And what we need is motion blur. Now what I need is some kind of material for these particles. Let's get particle info, and we'll use velocity to adjust particle color. We need vector math, and we need to get vector math length of velocity, basically absolute value of it, and then we can plug it in to color ramp and put it to base color. And nothing happened because I have this thing we plugged here. Also, let's make it from red to almost yellow, and I believe just the value of speed is not enough, so let's multiply it by something. Let's put it directly to surface, so there is no shading, and we'll see result immediately. What's wrong with you? Looks like velocity or angular velocity, whatever, is 0, and it has no in it. Do we have this thing baked? Yeah, we have. We can try and put this thing here, and it will give us some kind of randomization color, but it will be not aligned with velocity, and I'm not sure why, because this thing should work. Do we have same thing in render time? Let me show you. Rendering image, yes, we have same thing. Just one moment, please. I have some doubts, but it could be some kind of a very weird issue. What could it be? Okay, do not know, but maybe. It looks like there is no info on particles at all. Why? Where it is? Looks like everything's zero here. You know what? I believe I could forget one thing here. Nope. This is so weird because like a couple of days ago I did exactly the same trick for basically the same setup and it worked. Wait a minute. Nope. It's completely zero. Okay. You know what? Let me try and try a test project from a couple of days ago. And here we are. Let me switch Blender window. This. Okay. And whoops. Where it is. So it's basically the same setup. It's just the little background dynamic. It's running and ready. So let's check. Come on. Yep. We actually have faster moving particles and slower moving particles and shading. will shade them as I did in the file that I just created. I'm not sure what's the issue, but that's weird. I think what can I do here? Let's So yeah, it's basically the same code. Some post-processing. Let's move an emitter a little bit closer. So we'll have some So we have more actions in the attractor place, but not somewhere outside. Okay. You know what? Yeah, here we have one more thing, is a turbulence force, and this turbulence should add some basically turbulence to otherwise precisely calculated positions of particles, and it should result in a little bit more interesting look. Let's delete bake. Let's make the source a little bit bigger. But it still goes in the same place. What is it? It was an unexpected bug. Okay, we're moving. Moving. yeah, with turbulence that high, as you can see, particles do not converge to attractor point, so we have to find some balance. Okay, let's have it at 1. Whoa, that's interesting. That's kind of interesting effect. Okay. So, from like this side, we have particles to converge in this inner circle, but from this side, particles goes around this wide infinity symbol form. Nice, interesting. So basically we can have a close look at these particles, and we'll have a very interesting background created by second piece of an emitter. Okay, it was interesting observation. So let's bake all dynamic. Actually, no. Stop. Let's add a little bit more particles. Let's view them a little bit less in report, and let's go with bake all dynamics. Oh. But I still cannot understand what's wrong with this material issue. Why does it not use particle speed in the file I built on the stream, but it works fine on a file I already created a couple of days ago. Not sure what's wrong here. Okay, we're already there. Almost there. Come on. Just a little bit. Okay. here. Let's place it like this. Where's the focal point? Go here. Okay. All right, and let's hit F12. Actually, let's try and add some emission to this shader. Basically, I'll be using same thing. Emission and emission strength. Strength goes here, emission goes here. And here we have hue saturation, this. Okay. Here we'll have 0. Red one should not emit at all, in my opinion. And here we'll have some converter with multiplication. To get really bright particles like this. And one thing I believe I need to add is some kind of size randomization. I have it already, so I add a little bit more, and overall scale will be reduced like this. Okay, then let's see what we have. What we have in compositing: color balance, lens distortion, and glare. I guess we'll have to modify. Glare a little bit. Yeah. Well, I believe I'll go even further with scale, twice this little, and delete bake, and we'll increase particle number a little bit more. Let's reduce its amount in viewport 1%. Should be enough. This layout should not render everything. Lorenz, let's try and bake it all. Whoa. It will take some time, definitely. No, it's too extreme for me. What it was like 3 times less. Wake. Yeah, that looks reasonable. All right then. I'll wait until it finished baking and then do some render with it. Maybe some more adjustments, but basic idea, I guess, you already have. But maybe I'll wait. So whatever. I'm not in a rush yet. There is some time, and it's already almost 30% ready. By the way, how utilize my CPU and system overall. Okay. Okay, I guess video encode is my streaming. Okay, 50% is ready. But why CPU is so low on utilization? Hmm. $60. By the way, shout out to Carl Franklin, the author of the music which is playing in background, music to code by, great tunes to have playing in background while you're doing some kind of work that requires concentration, thinking. Come on. Okay, 20% left. Percents. And we're almost ready. Yeah. Finally. Oof. But it's actually nothing compared to like some fluid simulations in Houdini that one frame took like half an hour and 50 gigabytes of memory and cache. Okay, let's see what we have. Okay, not bad, not bad, not bad at all. Let's check some. How it starts. Whoa. Good. So I believe I'll render out animation with it and what? And upload it later. Let's check how it looks in dynamic width. Viewport displayed as points. Color, none. Oh, let's have it as velocity. And amount 1% and size a little bit less than we have here. Whoa, playback from cache is so slow. All right then. So I hope you'll got the basic idea with using Blender and Python in it for implementing some kind of mathematical visualization. For example, we have a Lorenz system here, but you can Google strange attractor and see a lot of other algorithms and formulas that have same property but different shape. There are a lot of them. They're kind of interesting. Feel free to change these constants. Feel free to subscribe and hit like whatever they're doing on YouTube these days. Also, I'll wrap it up as a text tutorial, so it's more search friendly, print friendly, and reader friendly. But yeah, I guess we have it. Thank you for your attention, and see you later.